learners, welcome back to Constant Learners. In the previous video, we discussed relational algebra. In today's video, we will start with the relational algebra operations. And the first one that we're discussing today is select or selection operation. We will discuss how select works with enough examples to understand the output that we receive when we use select in a query. Let's get started. We need to remember that relational algebra is a procedural query language that is actually used as a base for other query languages like structured query language. And why do we need it? To communicate with the databases. Now, relational algebra is used for relational databases. Relational databases are the one where data is stored in the form of tables or relations, that is, in rows or columns. Also, relational algebra is just like mathematics. In mathematics, we give two numbers along with the operation that needs to be performed, like addition, subtraction, multiplication, etc. And the output is also a number. Similarly, in relational algebra, we provide some input. Some operations are performed on the table inside the database corresponding to this input. And we finally receive an output. And it needs to be noted that the output is also in the form of a table, right? Now let's understand how exactly a select operation works. A select operation is denoted by sigma, which is a lowercase Greek alphabet. As the name suggests, select operation selects some data from the databases. That is, if you want to read or retrieve some data from the database, we can use the select operation. All right. Now, what data will be retrieved from the database? Whatever condition we are giving, right? So, another important aspect of select operation after sigma is the predicate or the condition. It is also known as predicate in technical terms, or the propositional logic. That means whatever logic we are applying to fetch the data from the database, that needs to be mentioned with the select symbol, right? And this predicate or the logic or the condition goes as a subscript of sigma. All right. So here as a subscript, we write the condition or the predicate according to which the data will be fetched. Now, what are these conditions? See, it could be any condition. For example, we need to fetch the students having marks greater than 7. So we are going to write it as a condition here, not like this, not like a statement, but it's going to go here in place of a predicate. If I have to look for employees whose name is Carl, so that will go here as a predicate, as a condition, because these are our conditions. This conditions or predicate will tell us what data exactly do we need from the database, right? And another important thing that we need is the table or relation from where we need this data. And it will go here in the round bracket. So we write the name of the table or the relation from where we need the data, right? We will understand this when we see the examples. Now, finally, what the output would be? The output would be an entire row or tuple. This we need to remember very well, that select operation fetches the entire row or the tuple that will follow this predicate or condition, that will fulfill this condition, right? But the output will be in the form of a table. But this table will contain the rows that will satisfy this condition, all right? And these rows will have all the attributes or all the columns that are present in the original table. Let's understand this properly. See, for example, I need the names of students whose name is Carl, right? Now here we have two Carls, 102 Carl, 104 Carl. So we are going to write the query. It will start with sigma. The predicate will be name is equal to Carl. So that will come as the condition here. And the name, or when we're talking about alphabets, it goes inside the double inverted commas, right? And finally, we need the name of the table, which is students, that goes inside the round bracket. So this is our query. Now, what data will be fetched? Which rows will be fetched? Both of these rows, because both of these rows have the student's name as Carl. But the output will contain all the tuples that fulfill this condition. That means this tuple and this tuple, along with all of these attributes. All right. So select operation selects entire rows. That means that contain all of the columns that are present in the original table. Like here, we have all the columns: roll number, name, department, marks, right? And the students with names Carl are given as the output. Let's see some more examples. Get the names of all the students that are in the IT department. Now, this is the same table. We have roll number, name, department, and marks. We need the students who are in the IT department. Here, there are two students, IT. One is Carl and the other one is George. Let's write the query first. We start with sigma. Now, the condition here is department is equal to IT. Again, IT will go inside the double inverted commas and the name of the table, that is students. So, what will be the output? Output will contain both of these rows. The 102 Carl IT 46, 105 George IT 63, right? And the output will have all the columns, all the attributes that are present in the original table, all right? And the output will be in the form of a table itself. So this is the output table, all right? This is not changing the original table. This is not the students table. This is the output table. Let's see the next example. Fetch the names of all the students that have scored marks greater than or equal to 50 and are in the CS department. Now here we have two conditions. One, the marks have to be greater than or equal to 50 and are in the CS department. That means both the conditions should be satisfied. That means marks must be greater than or equal to 50 and the department must be CS. When both of these conditions are satisfied, only then we will receive that row as an output, right? Why is that so? Because here we have and. We are not saying or, right? So let's see. Here Jack is in CS, has marks 78. So this satisfies our condition. Here Sarah is in CS, marks are 88. Again, this also satisfies the condition. Then we have Carl in CS, but the marks are 49. Now CS, department CS is being satisfied. This condition is true, but marks are less than 50, which is not true. Hence, this row will not be present in the output. Let's write the query first. We have sigma, then marks greater than or equal to 50. So here we have marks greater than or equal to 50 and. Now this is the logical and sign. The department is equal to CS. Now see, numbers do not require double inverted commas, but the text does. Alright. And finally the name of the table, that is students, going inside the round brackets. Now the output will contain all of these two rows, because in both of these rows, both of these conditions are getting satisfied. When we have and, it is important that both the conditions should be true. All right. And we can have as many conditions as we like. So the output has Jack CS 78, Sarah CS 88. And the output has all the attributes that are present in the original table. Let's look at another example. Fetch the names of all the students that are either in the IT department or in the CS department. Now here we have or, right? The condition is not and. That means if the student is in IT department, he will appear in the output table. And if he or she is in the CS department, then they will also appear in the output table. Any one condition has to be true. So how do we write the query? Sigma, department is equal to IT or department is equal to CS. Now this sign here is the logical or sign. All right. So if department is IT, it will be present in the output. If department is CS, it will be present in the output. That means any of the one conditions have to be true. It's not necessary that both conditions have to be true, right? Now here, Jack CS, that means this will be in the output table. Carl is in IT. This will also be in the output table. Sarah CS will also be in the table. Carl CS, George IT. All of these students will be present in the output table. Then we need to mention the name of the table, that is students. Now our query is complete and the output will have all of these rows. All the students that are either in CS or IT department. I hope all of these examples were clear. Now let's quickly discuss the relational operators and logical connectors that are allowed in the select operation. First is equal to, that we've already seen. Then we can also have not equal to. That means marks are, select all the students where marks is not equal to 0. So that will be another relational operator that can be allowed. Then greater than, marks greater than 50, marks greater than equal to 75, marks less than 40, marks less than or equal to 40. All of these operators can be used in the select operation. And the logical connectors that can be used are and. I've already explained that both the conditions have to be true, or we can say all the conditions that are present using the and operator should be true. In case of or, Any one condition, if it is true, then it will be present in the output. And finally, we have the not or the negation operator. I hope all of this was clear. If you like this video, don't forget to give it a thumbs up. If you have any queries, write it in the comment section below. Subscribe to the channel, and thank you so much for watching.